Welcome, Math 13 students. I have here a video that ties together sections 10.1 and sections 10.2, the two pieces of chapter 10 that we take a look at, correlation and regression. They really go together, and they really sort of need to be done at a single time. You really want one unifying example to sort of bring it all together, and that's what I have for you here today. So follow me over to my other screen, and we'll go ahead and get going. No new keystrokes. All right, chapter 10, the unifying example, correlation and regression. We have a complete example for you here. Bit of an outline first. We're going to combine the detail from 10.1 and 10.2 and give you a unifying example. We'll generate a scatter plot. We'll address a claim of correlation. We will conduct a test for that claim of correlation. We will find the regression equation, and then we will go ahead and use the regression equation. You have all the keystrokes in other videos in this particular couple of sections, so I'm not going to waste a lot of time on the keystrokes, but we'll take a close look at your calculator output as we go through this. The claim and the data. Well, we have a random sample of statistics students, and they were evaluated on the number of homework exercises they completed and a grade on an associated exam. So here's the data. It's just X and Y data, X for problems completed, Y for exam scores. I know we got a couple of columns there, but we got a lot of numbers. So those are the values that need to go into your calculator. List 1 will be problems completed. List 2 will be exam score. You should only have 2 lists for this entire problem. Total of, I think it's 12 data points, 12 ordered pairs. Now, once you go ahead and get that input into your calculator, we can begin addressing the questions. The first thing we'll do is generate a scatter plot. I always like to look at my data first and ascertain or determine if it's got an essentially linear sort of pattern to it. So we're going to do that. X is going to be the problems completed. Y will be the exam score. If you plug that into your calculator and you go through the keystrokes we did in 10.1, you'll get a graph that should look about like that. You'll notice that there is a general upward trend from left to right, and it's reasonably linear. So this is the sort of data we really truly like to run regression analysis on. So there's your scatter plot. Here's the test. We're going to test the claim that the number of problems completed is correlated with exam scores. That means rho is not equal to 0. We're going to use an alpha of 0.05 and the p-value approach. So I'm going to run through all 5 steps of the hypothesis test, the null and the alternative, the p-value, the comparison with alpha, the test outcome, and then we'll address the initial claim. So the claims first. The null, rho equals 0. The alternative, rho is not equal to 0, and that is the initial claim. We have a claim of correlation. Correlation is the alternative hypothesis. No correlation is the null hypothesis. Now, we'll point our calculator at list 1 and list 2. We'll run the linear regression t-test, and I can see I've got a p-value of 0.00378933136, and probably a bunch of other numbers too. 3 significant digits. It is a probability. 0.00379 is my p-value for this particular test. I'll compare that to my level of significance of 0.05, and it is handily less than 0.05. And whenever the p-value is less than or equal to the alpha, we reject the null hypothesis. If we rejected the null hypothesis, the data supports the alternative hypothesis, which is the initial claim. So there is enough evidence to support the claim that rho is not equal to 0 at the alpha equals 0.05 level. Now, what does that really mean here? It means the correlation is useful, and we'll be able to use problem sets to estimate exam scores. That's really the whole idea behind regression. And here we go, the regression equation. We're going to find the regression equation and round the coefficients to 1 decimal place. Now, The regression equation is on the exact same screen as the linear regression t-test outcome. This is why I say the problems really need to be done together. So y equals a plus bx, or y hat equals b naught plus b1x if I want to groove upon the notation of our text. A and b are down there. I'll round those to 1 decimal place. So we have y hat. Yes, we need the little hat. Equals 43.1 plus 0.4x, where x is the number of problems. So we've now found the regression equation, and we'll go ahead and use it. So we will use that to estimate the exam score for a student who does about 70 problems. So if you've done 70 problems and you're getting ready to take your exam, what might be the estimated exam score? Well, when I plug the 70 in, I get y hat equals 71.1, or more likely 71. I'll round to the nearest whole number. So the estimated exam score is 71. So what have we done? We've taken XY data, we've tested for correlation. Once we tested for correlation, we find the regression equation and then use it. Those things all go together. So in summary, we've combined those details from 10.1 and 10.2, did a scatter plot, addressed the claim, conducted the test, found the regression equation, and then used that regression equation. So that really is the meat of what you need to know for Chapter 10. There we go. I'm done now. I'll say goodbye. I'll stop sharing. And I will point out that this particular set of exercises in 10.1 and 10.2 is very calculator intensive. It also has some of the gnarliest equations that we encounter all semester long. If we were in a face-to-face situation, I might run through one of those with the ugly formulas, but in general, we really truly use our calculator here for the regression equation. All right, we'll talk to you later. Bye-bye, and bring me your homework questions. Thank you.